Okay, so now we're going to be starting to solve equations that are quadratic. So you'll notice that in each of these equations there's like an x squared or an m squared. Also, we're not just purely factoring anymore. If you noticed previously when we were factoring, it was always just an expression. There was no equals. Now that there's an equals, our final answer should be stuff like m equals or x equals. Okay. So you're going to be using your factoring methods. Always look for a GCF first. You'll notice in this case I have 3 terms, so it's a trinomial. It is not a tricky trinomial because there's nothing in front of the m squared, so I can use regular AM method to factor this trinomial. So I'm going to put 2 sets of parentheses. M and m are going to start them. I'm looking for 2 terms that multiply to 56 and add up to negative 15. Now, as I had said before, if you get stuck and you're like not great with figuring out factors of a number, take the number you want the factors of, 56, type in 56 divided by x, take a look at the table. Once the left-hand side is bigger than the right-hand side, there's no further options, and you can see right here 7 and 8 are our combination to multiply to 56 and add up to 15. They're going to have the same sign because they're multiplying to a positive, and both those signs are going to be negative. Now, you'll notice that in this problem, again, it's not just factoring for the sake of factoring. Now you're solving an equation. What happens is you have a number multiplied by a number that comes out equal to 0. The zero product property states that when 2 things multiply to be 0, either the first thing had to be 0, m minus 7, or the second one had to be 0, m minus 8. So now you have basically 2 smaller linear equations to solve, and that's how you're going to end up getting your values of m that satisfy this equation. So I add 7 to both sides. That gives me m equals 7. And I plus 8 to both sides. That gives me m equals 8. And then my solutions are 7 and 8. You're not really required to put it in a solution set, but I think it's just like a neat way of writing out all of your answers in one space, so it's easier for whoever's grading you to find your solutions. Okay, so you'll notice with the first example, the quadratic equation was already equal to 0, so we could use that zero product property. If you notice you have a quadratic and it's not equal to 0, that's what you have to do first. You have to get it equal to 0 or you won't be able to use that zero property. So I'm going to start by bringing everything over to one side. Generally, I want to try to bring it on the side with the x squared because I want to try to keep x squared positive. So this becomes x squared plus x equals 0. Okay, a lot of people get stuck with questions like this because they start trying to do some weird trinomial factoring. This is not a trinomial. Just because it begins with x squared doesn't make it a trinomial. There are not 3 terms. 2 terms means it's either only GCF or dots, and clearly in this case, it's GCF. So I can factor in x out of that expression. I have an x plus 1 left over when I factor out that x. And now I'm going to split. And here's another thing that people make mistakes with. That x that I factored out, that is an actual factor of this expression. Either x has to be 0 or x plus 1 has to be 0 to make this equation true, that these multiply to be 0, and that's going to actually give you another solution. So if you don't put x equals 0 or you divide away that x or something like that, you're missing a whole solution that you need to have a complete answer. So I minus from both sides, and I get 2 solutions, x equals 0 and negative 1. Okay, so my last one, once again, not equal to 0, so I'm going to start by getting everything onto one side. I want to write it in descending order, 2x squared plus 3x minus 2 equals 0. You'll notice that in this case, I have a trinomial, but I unfortunately don't have a GCF that's going to remove that 2 in front of the x squared, so it's a tricky trinomial. So remember, for tricky trinomials, we want to turn this into a factor by grouping problem. You're going to multiply the first and last numbers, negative 4, that's your m. Your a is always your middle term. You're using that am to split the middle term. You're always keeping your first term exactly the same and your last term exactly the same. And again, by splitting the middle term, we'll be able to use factor by grouping to finish factoring this. So what multiplies to make negative 4 and adds up to be positive 3? Well, the only factors of 4 are 1 and 4 or 2 and 2. So you can clearly see here it's 1x and 4x. Okay, so they're multiplying to be opposite signs. The sign of the middle term is going to go with the larger number, so positive 4x, negative 1x, and again, remember, you're splitting 3x up. Now that you've gotten it to be 4 terms, we can continue with factor by grouping. Chop it down the middle, GCF the first half of the expression. The second GCF is going to be positive because the sign after the split bar. I can factor out a 2, and I'll be left with 2x minus 1. Remember, to know that you're doing factor by grouping correctly, you'll have to have the same parentheses in each half of the expression. So now I have this 2x minus 1 that I can factor out to the front. and what will be left over will be x plus 2, whatever was left over as those GCFs. So again, like I'm removing the 2x minus 1 to the front, and everything else gets left over. So now I'm going to split this and set each of these factors equal to 0. So 2x minus 1 equals 0 would give me 2x equals 1, and when I divide both sides by 2, that gives me x equals 1/2. And when I have x plus 2 equals 0, I minus 2 from both sides, and this gives me x equals -2. So my solutions are x equals 1/2 and -2. We're going to talk a little bit later about how to solve this with a different method if you really don't feel comfortable with tricky trinomial factoring. I will point out, if you are solving something as a tricky trinomial, you're always going to get one of your solutions to be a fraction, if not both of them. Okay? Okay. So now we're going to get into solving quadratic equations that don't necessarily, are not able to be factored, but usually quadratic formula is meant for situations where either you can't factor or you're not great with factoring. So for example, if you're not good with tricky trinomial factoring, this would be a better option for you. The good thing is this is a formula that's given to you on the reference table for the regents, so you don't really have to memorize it, but it would be helpful for you when it comes up in your future years of math to have it memorized. X equals -b plus or minus square root of b squared minus 4ac all over 2a. So you might be wondering, where do these a, b's, and c's come from? Well, they come from when you have a quadratic equation in standard form, ax squared plus bx plus c equals 0. Okay, so the coefficient of the x squared is your a, of the x is your b, your regular number is your c. Just like you can see right here, just like when we were solving quadratics with factoring, you first want to get it equal to 0. So if you take a look at number 1, I'm going to minus 2 from both sides to get everything on one side. I have 2x squared plus 3x minus 2 equals 0. Okay, so this tells me that a equals 2, b equals 3, and c equals -2. So I'm going to start plugging these in, and you have to be super careful with your signs. So -b is going to be -3, plus or minus square root. B squared is 3 squared minus 4 times A times C all over 2A, 2 times 2. This is the place where you have to be careful. That is where everybody always makes their mistakes. My suggestion would be plug the whole thing exactly like that right into your calculator. So I'm going to type in 3 squared minus 4 times 2 times -2. Notice I'm typing in it exactly the same way that I wrote it out, and I can see that 25 is going to go underneath that radical. So I have -3 plus or minus the square root of 25 all over 4. So you're lucky in this case because this one actually turns out to be a perfect square, so I can turn that into the -3 plus or minus 5 over 4, and that's going to give me two solutions. -3 plus 5 over 4, and x equals -3 minus 5 over 4. As I simplify this, -3 plus 5 would be 2. 2 over 4 reduces to 1/2. -3 minus 5 would be -8. Divided by 4 is -2. So your solutions in this case are x equals 1/2 and -2. Now you'll notice because you're getting solutions that come out to be fractions and whole numbers, you're getting rational solutions. That meant this was actually a factorable equation. If you go back to when we were solving problems with tricky trinomial factoring, I actually did this one earlier and we got the same answers. So again, it's up to you. If you're not great with tricky trinomial factoring, do quadratic formula, but just be super careful with the part where you're plugging in the b squared minus 4ac. Okay, question number 2. Also actually could be solved by factoring, but I'm going to solve it with quadratic formula just to show you examples of ones that come out to be a little bit different. So I first want to get the whole thing equal to 0. Now you'll notice that I'm missing an x term, so I'm actually going to put a 0x in there as a placeholder. -18 equals 0. So this means that a equals 2, b equals 0, and c equals -18. So I'm going to plug that into quadratic formula. And again, be super careful when you're plugging it in. -b would be -0, although really writing -0 isn't going to change anything a little later. Square root b squared, which would be 0 squared minus 4 times 2 times -18. Again, be so careful with the part with the b squared minus 4ac. Divided by 2a, which is 2 times 2. And as I said before, I would suggest plugging that exactly as you see it right in your calculator. 0 squared minus 4 times 2 times -18. Comes out to be 144. So that 0 is just going to go away. I do need to keep that plus or minus. So plus or minus 144 divided by 4. 144 is once again a perfect square. So I get plus or minus 12 divided by 4, which comes out to be plus or minus 3. So my solutions are 3 and negative 3. And like I said before, if you're getting solutions that come out to be whole numbers or whole numbers and fractions, it means you're getting rational solutions. So it means you probably could have solved that by factoring to begin with. But again, this is just an alternative if you know you're not great with that factoring. Okay, so now our last one. So this one's not going to be able to be solved by factoring. This is where you definitely need quadratic formula, and we're just going to leave our answers in radical form. So once again, I want to get the whole thing equal to 0, so I bring 3x over onto the left. So I have x squared plus 3x minus 3 equals 0. This tells me that a equals 1, b equals 3, and c equals negative 3. So I'm plugging into my quadratic formula. Let me just do this. Plugging into my quadratic formula. X equals negative b, negative 3, plus or minus square root 3 squared minus 4 times 1 times negative 3 minus 4ac all over 2a. I feel like I cannot stress enough how much you need to be careful with the part that's underneath the radical. So 3 squared minus 4 times 1 times negative 3 comes out to be 21. So negative 3 plus or minus square root of 21 all over 2. Believe it or not, that's actually your answer. Since radical 21 cannot break down, which again we'll talk about radicals a little later, but since that can't be reduced, if you wanted to write it as two solutions, you could say negative 3 plus radical 21 all over 2, and x equals negative 3 minus radical 21 over 2, but actually, believe it or not, this would be perfectly fine if you just wanted to write this as your solution set. Okay, so another alternative for solving quadratic equations, and obviously it's not people's favorite, but it's completing the square. It's just a different option, and the thing is, on the Regents, sometimes you get asked questions that are specific to completing the square, or you might get asked to specifically use completing the square. So it's good to go over this process. It's really helpful for when you have situations where, let's say, you don't have a calculator, because you'll be dealing with smaller numbers and things like that. But again, if you ever got stuck, you could always use quadratic formula. Quadratic formula completing the square can be used interchangeably. Okay, when you're solving stuff with completing the square, this is the one time when you're solving a quadratic equation and you don't want to get it equal to 0. What you want to do is get all your x's to one side, all your regular numbers to the other side. So I'm going to add 10 to both sides, and I'll have x squared minus 6x equals 10. So now the goal is to take that x squared minus 6x and turn that into a perfect square trinomial. Turn that into something that when I factor it, it will come out to be the same factor twice, and that will be important for a little bit later. So I'm going to find a way to add something to this left-hand side to turn that into a perfect square trinomial, and remember that when you add something to one side, you add it to the other, so that's why I look to put a plus blank on each side, so I can make sure I remember that. The way you're going to figure out what you're going to add to both sides is you're going to take your middle term, divide it by 2, and square it. Forget about the negative, because when you square something, it comes out to be positive anyway. 6 divided by 2 is 3. 3 squared is 9. That's how you're going to end up turning the left-hand side into a perfect square trinomial. So think about doing AM method on the left-hand side. What adds up to negative 6 and multiplies to 9, when you factor it, like I said, you've engineered this so it should come out to be the same parentheses twice. It would be 3 and 3. They're both going to be negative because they multiply to a positive and add up to negative 6. Instead of writing them in this way, you're going to write it actually as x minus 3 squared, and on the right-hand side, I'll have 19. So why did I want to write this as x minus 3 squared? Why did we do this whole process of completing the square? It's because now to undo this x minus 3 squared, I'm going to take the square root of both sides. So I have this x minus 3 squared equals 19. Take the square root of each side. I'm going to finish it up over here. When you square root something squared, it comes out to just be x minus 3 by itself, the radicand with no more power and no more root. On the right-hand side, it's very important you remember there's a plus or minus version of that square root of 19, and thankfully 19 cannot break down, so you're just going to leave it like that. To finish up, I'm going to add 3 to both sides. I cannot combine a regular number with something in a radical, so this is just going to be 3 plus or minus the square root of 19. That's actually perfectly fine if you want to leave your solution like that, or if you wanted to put it as two separate solutions, 3 plus rad 19, 3 minus rad 19. Okay, so like I said, you would do quadratic formula and get the same exact answers as you got right now. It's just smaller numbers when you're doing completing the square, so it's good for situations where you don't have a calculator. Now it's important when you look at question 2 that to do completing the square, you cannot have anything in front of the x squared. So if you notice 3x squared, 6x, 15, they're all divisible by 3. I'm going to reduce all of them by dividing out by 3 and make my numbers a little smaller and make it able so I can do quadratic completing the square. So this comes out to be x squared minus 2x minus 5 equals 0. So again, you would try to factor this. Unfortunately, this is not factorable. You can't find anything that adds to -2, multiplies to -5. That's where I would come in to use either quadratic formula or completing the square. So to do completing the square, you move your regular number to the right-hand side. Okay, keep all your x's on the left. You're going to end up making it become x squared minus 2x plus blank equals 5 plus blank. You want to add something to both sides to turn that into a perfect square trinomial. So I divide this by 2, which becomes 1, and I square it. Okay, so the middle term gets halved and squared, and that's how I know to add 1 to both sides. When you factor x squared minus 2x plus 1, just like the previous problem, it comes out to be the same parentheses twice. It's going to come out to be x minus 1 times x minus 1, which is better written as x minus 1 squared. 5 plus 1 comes out to be 6. And now that you've gotten into this form where you have the left-hand side being squared, it's easy to undo the squared by now taking the square root of both sides. The left-hand side turns into just x minus 1. The right-hand side becomes plus or minus radical 6. Do not forget the plus or minus. When you solve a problem by taking a square root, you must have the plus or minus there to get all of the solutions. Add 1 to both sides, and now I have x equals 1 plus or minus the square root of 6. And like I said, that's perfectly fine if you want to leave your answer like that, or if you felt like splitting it, 1 plus rad 6, 1 minus rad 6. Okay, last but not least, same exact process. Again, it's an easy process if you practice it a couple of times. I know it's a little overwhelming at first, but it's the same steps over and over. Get all your variables to one side, all your numbers to the other, complete the square, take the square root, end up moving your x to get by itself. So in this problem, I have to get it so that all of my variables are on one side and all of my regular numbers are on the other. So I'm going to start by minusing 2n to get all my n's on the left, and minusing 5 to get all of my numbers on the right. So I have n squared plus 2n equals 7. Okay, so n squared plus 2n plus blank equals 7 plus blank. You're turning the left-hand side into a perfect square trinomial so that you'll be able to eventually, write it as something squared and take the square root. Take the middle term, divide it by 2, and square it. That's how you know that you're adding 1 to each side. So I have n squared plus 2n plus 1, which will factor to be n plus 1 in parentheses squared. Just do AM trinomial factoring like we did at the beginning, and you'll see the same parentheses happen twice. That's why you're writing it as being squared. On the right-hand side, 7 plus 1 comes out to be 8. As I get to the point where I have n plus 1 squared equals 8, the whole point of putting it like this, completing the square, writing it as something squared, is so I can now use the square root to undo that that n plus 1 squared. So this will leave me with n plus 1 equals plus or minus the square root of 8. Again, do not forget that plus or minus. I would suggest that you break down radical 8. Again, we're going to talk a little bit more about breaking down radicals in one of our future lessons, but just for now, 8's not too big. 8 is really the same thing as 4 times 2. 4 being the perfect square means that you'll put a 2 on the outside and you'll leave this 2 left over underneath. So I get n plus 1 equals plus or minus 2 radical 2, minus 1 from both sides. Once again, keep in mind that -1 cannot be combined with the 2 radical 2 because I don't have a common radicand, which again, we're going to go over a little bit more in one of our future lessons with regard to talking about radicals.